Welcome to the course of Materials and Metallurgy. So this course basically consists of 3 credits total, and we have a 45 hours course. Now the course basically consists of introduction to materials, history of materials origin, scope of material science, overview of different engineering materials and applications, classification of materials. We'll discuss about the thermal, chemical and electrical and mechanical properties of various materials, the present and future needs of materials and overview of biomaterials and semiconducting materials, and various types of issues that are related to the materials such as economical, environmental and social. Now, what are the course objectives that the student learning? Understand the material properties, analyze the material structures, interpret phase diagrams, explain the metallurgical processes, analyzing the heat treatment techniques, evaluate the material selection, foster innovations in material engineering, promote sustainable practices. Now, the course outcome consists of the classifying the engineering materials, analyzing microstructures, interpret phase diagrams, applying metallurgical techniques, optimize material properties, select the material for the application, solve the different types of engineering problems, embrace emerging technologies, promote sustainability, communicate technical knowledge. Now, when you talk of introduction to the materials have been classified into 4 main types: metal, ceramics, polymers, composites. So these we'll discuss in the details. Then related to the density of the material, this graph predicts the various types of materials and their values in terms of the density. So here you can say the metals are having the highest density. Then we will be discussing about the smart materials. In the smart materials, we'll be discussing about the piezoelectric materials. We will be discussing about the shape memory alloys, electrological and magnetological fluids, thermoelectric materials, self-healing materials. Now, when you talk of the history of the materials, we have the Stone Age material that are 3000 BCE. In this, you can see how the early human relied on natural materials like stone, wood and bone for tools and weapons. And we have various different types of clay, potteries and other functional items. They are come under the history of the materials. Now, when you talk of the Bronze Age is in between 3000 to 1200 BC. So, the discovery of metallurgy begins with the smelting of copper and its alloying with tin to create bronze. So, bronze tools and weapons are harder and more durable than the stone revolutionary agriculture, warfare, and art. So, civilization like Mesopotamia, Egypt, and the Indus Valley advanced their societies with bronze. Now, the Iron Age. When we discuss of the Iron Age, iron extract from ores, steels and other alloys was introduced, enabling stronger tools and weapons. So they come under the Iron Age. Then we have the Middle Age. Middle Age range between 500 CE to 1500 CE. So in this we have the advances that were held in blacksmithing, metallurgy, refining, production and steel, use of glass in architecture and flourish, especially Catholic cathedrals. Gold, silver, and precious gemstone became symbols of wealth and power. Then we come the Industrial Revolution in the development of coal, coke-fueled blast furnaces, material like cast iron, wrought iron, high carbon steel, construction products including bridges and railways. Advances in chemistry led to the development of synthetic materials like rubbers. Then we come towards the polymers and advanced materials. So you can see in this particular image, we have various types of applications such as your medical devices. You have the pH sensor, drug delivery, robotic skin, smart fibers, self-healing materials, shape memory materials. Then with respect to the temperature, light fields, electric fields, magnetic field. Now we come to the modern era. In the modern era we have the high tech and sustainable materials. Nanomaterials and composites enables high performance applications in aerospace, medicines, energies. Biomaterials and biodegradable plastic supports advancements in medical implants and eco-friendly products. Research focus on sustainable materials, recycling technologies to reduce environmental impact. Smart materials with adaptive properties like shape memory alloys, piezoelectric materials are being integrated with the robotics and sensors and electronics. So we will be starting our course of the materials and metallurgy. Thank you.